I'm taking a little break from working underneath the chassis to go topside. In particular, I want to examine the components inside the high voltage box and test the picture tube. So, I took off a few sheet metal screws that were holding the box on and removed it. And let's see what we've got. So, here's a power resistor I was talking about earlier. 8500 ohms, 25 watt. No, they don't seem to make these anymore, unfortunately. Closest thing would be 10K. And I think I might have some. If so, then I can, and by that I mean with this style, chassis mount. They put a mica washer below and on top, metal washer, and then a screw through it to secure it to the chassis. They do make 10Ks. Yes, they're a bit expensive. I think I might have some, and then I could put a resistor in parallel with it to get 8500. I think 20K will do it, something like that. But what they did was they strung together some of these cement type power resistors and just kind of let them flop around in here. Let's see. I'm guessing we got three 2.7K in series. A little slow today. What's that, 8.4? 8.1? Something like that. Well, and obviously that wasn't connected very well together because it just fell apart. So that's got to get rectified, so to speak. And I noticed right away that the flyback is a replacement. I don't ever think I've ever seen a replacement flyback in an Admiral. The flybacks these sets use are common to a lot of late 40 sets. You'll find the same thing in RCAs and a lot of other brands, and they're pretty reliable. That's why I'm kind of surprised. And as we noted in the first part, when the chassis was dropped off, this is broken off. So it should be a pretty simple repair, I hope. Assuming the flyback is still good. I suppose I'll look that up. It's a Ram X036. The Thord Arson, I believe, is a fly number 1. And that's what they use in the RCA 630 TS, which is kind of the first mainstream TV. So I think that's why the very first replacement flyback number 1 got that designation. I also noticed that we've got an Admiral tube here, the high voltage rectifier. However, that script is kind of a later style Admiral font. So I don't think that that's necessarily the original tube. Let's see if we can find, here's one that could be. This guy out here. That is the old school Admiral font. And sometime in the 50s they changed it to the one on the right. It's a 6S and so, alright. That would be a 6BG6. That's definitely a later style because it's got straight sides. It's not the old Coke bottle like would have been in here. And that's all that's in there inside the box. You got well, I shouldn't say that now. Horizontal output tube, flyback, high voltage rectifier, a big old tube, or sorry, power resistor that goes across the damper, I think. Pretty critical to the operation. Without this, you get some horrible ringing and crazy nonlinearities and stuff. So definitely that needs to get replaced. Oh yeah, the other thing I want to point out is this guy down here. That is what they call a doorknob capacitor. That is a high voltage filter cap. Typically they're 500 picofarad, probably rated for 20,000 volts. Rarely go bad. I've never found a bad one. And then there will be 2 resistors under here that often get overlooked. One of them should be either in parallel or series with the, it's in series with the filament on the high voltage rectifier. I think it's there as a little kind of current limiter safeguard to make sure you don't burn out the high voltage rectifier. The other one is a 1 meg resistor that's in series with the high voltage lead going to the CRT. Those often get overlooked. They can drift in value, especially because there's a lot of corona potentially down here and high voltage, and that can do weird things to these carbon resistors over the decades. And that it's directly in series with this high voltage lead. So if it goes bad, you're not going to get the proper high voltage going to the picture tube. That is what this is all about. It snaps in up there. So, take out these 4 screws, carefully flip the thing on its side, and you can replace those 2 resistors. And somebody's already done the hard work of cleaning this out, because the high voltage down here also typically attracts a lot of fine dust particles. I can clear. So these pillars are usually not gleaming white ceramic, they're porcelain, they're usually kind of black. There'd be like black soot over everything. That ring down there is called a corona ring. That is connected to the high voltage, and it kind of keeps everything at equal potential around this area with no sharp edges to suppress any irking. Alright, so that's all that. Picture tube base loose, or was loose. I got some glue in there. This is the kind of stuff I typically use. It's pretty thin, has a little bit of give after it sets up. It is silicone type adhesive, but most importantly it does not have acetic acid in it, which can corrode copper. Sensor safe is another term for it. Good stuff. And it bonds well to glass. It's windshield and glass sealant, so it bonds well to glass. A little bit of give is nice to have in these because of the thermal coefficient of expansion between the glass and this base might not be a perfect match. So you can see this base actually has a crack in it. So it's nice to have a little bit of give, a little bit of play. While that sets up though, I will go ahead and test it. There's no point in doing all this if the picture tube's no good. The picture tube tests just fine, good emissions, good cutoff. Got the base secured. We're working down in this area. I hunted all around. I could not find an 8500 ohm power resistor in the style, but I did find a 7500 ohm. It's exactly the same size. So what I'm going to do is remount it. So these mount on a mica washer, and there's a tapped hole in the chassis, so it goes like that, and then like so, and then the top has another mica washer, and a metal, and then a screw, so that all goes together nice and neat. But we're 1K off, so I'm going to add a 1K resistor in series with it. One end goes to a wire down below, so I could add it down below the chassis, or the other end goes to 2 points. If it was just one, this terminal strip here, that'd be great. I'd add a 1K resistor like that. But there's also another wire that goes to the flyback, and the wire's not long enough. I am inclined to put the 1K resistor here, so if somebody looks inside this box, it should be pretty obvious what's going on. They don't have to hunt down around below to see what modification was made, so I will... Well, I guess I could reuse this wire. So this wire you may notice is a bit different than this. I've noticed that on some sets from the late 40s where they have a mix, or even in the 50s, that's for sure. I think this wire has a higher rating. Inside, there's like a thin plastic insulation right against the wire, and then it's outer cloth covered, so like 2 layers. It seems to be using either more demanding applications voltage-wise or heat-wise. I also typically see this on like the AC line coming in, and you can see that's what they use on the flyback. Not everything. This is plastic. Well, maybe it's just they used what they had, or when maybe some of these things came pre-assembled and they had wires attached like on the flyback. I don't know. But anyways, I'll reuse what I can. As far as like the wattage on the 1K resistor, well, power distributes evenly across the resistance, so if we got 25, this won't dissipate a full 25 watts. It'll probably be like 10 watts. I mean, they tend to overrate these things, so You know, they tend to be very conservative when specifying power resistors so they don't burn out. But anyways, let's say it is 25 watts over 7.5K. We're going to add 1K, so basically it's like a 7-to-1 ratio. 8 times, well, 5 watt 1K resistor would be just fine. I also took the screws out of this, so I should carefully bend it over. A little tricky, but there are those resistors, which are looking pretty crummy. So that should be a 1 meg resistor. That looks kind of fried, so I'm curious. I'm going to measure it now. See what we get. That's that done. I'm glad I went through and did this. The 1 meg measured about 1.3 meg, which isn't terrible, but the 3.3 ohm measured over 10 ohms, about 3 times what it should be, which is going to restrict the flow of current through the rectifier tube filament, which will make it not run as efficiently as it should, and it will reduce the high voltage current going to the picture tube. Now this is one case where you want to be a little sloppy, and by that I mean use an excessive amount of solder and make big old blobs on all the joints. I even turned the wattage down on my soldering iron to make that easier to do, because when you're dealing with high voltage you don't want any sharp edges. That's why they got this ring down here, that's why they got this donut up here. High voltage collects on sharp points, and that's where you can get some corona. In addition, you may notice there's some red coating on some of these lugs. There was down here as well, but I burned it off when I put that resistor on there. Let's see, I gotta touch up that film and lead a little bit too. Snug that down. That is an insulating paint. I believe they still make it. It's like red insulating varnish, something like that. It's good for several thousand volts per thousandth of an inch. I don't have any, but they do still make it, and I should pick some up and coat it. Corona dope works even better, but it's more expensive, more volatile, and so on. And we're only dealing with like 9 or 10,000 volts, so we don't need to go too crazy. So I'll touch up that one joint. I can see the filament wire's a little loose, and then I'll resecure this, and I got my 1K resistor ready to go. That will just slide in there like that, and this wire will get routed over there, and that will be that. Nice, neat job. Back out of the chassis now, and for the second time I've encountered a 0.01 microfarad cap where there should be a 0.001. I don't know if whoever worked on this just didn't have them and thought that it wouldn't matter, or I'm working back underneath the chassis again, and for the second time I have found a 0.01 microfarad capacitor in place of a 0.001. I don't know if whoever was working on this just didn't have any and didn't think it would matter, or didn't notice. I don't know, but one there, and that originally actually was mica. I saw from looking at reference photos. I think film will be okay. And now another one. And the horizontal discriminator circuit, this guy right here, I found at 0.01. Well, I'm putting all the right values in as I go through this, so it's getting to be a little tedious, I admit, but I just hope it'll all be worth it in the end. A box just arrived that should contain everything I need to finish this Admiral project, plus something else. Lately I've been ordering a lot from Mauser. It hadn't occurred to me to check out DigiKey, so one of my viewers left me a comment. He knew that I'd been looking for wire, and he had a fantastic suggestion with DigiKey. This is the stuff I've been looking for. 22 gauge solid core, 600 volt rated plastic insulation. Yes, it does still exist. It's a little hard to find. So I got a bunch of it, different colors, 100-foot rolls. This should last me a long time. It's made by General Cable / Carroll brand. They didn't have a ton of it in stock, but they had 5 to 10 rolls, it seemed, of all the basic colors. So that is the stuff I will be using on all my upcoming projects. And I got some other odds and ends, but most importantly, it's what's in here. These little blue caps. Some of you remember seeing some predictive videos I did a few years back where I made my own cup plates. These are what I used. These little blue guys are C0G temperature and capacitance, stable ceramic type capacitors rated for 630 volts. So that's what I'll be using to replace those ones where we just found kind of generic ceramic caps in there. And there should also be this. Here we go. And these are real mica caps. These will go into the sound IF cans. Got a couple 30s and a 36. Original was 35. I doubt the tolerance was that tight back then to make that big of a difference. Plus, they are adjustable, and I will need to align this. Anytime you replace the caps in an IF can, you're gonna have to align it. Things aren't going to be exactly the same value as what was in there. So, luckily, it's pretty straightforward to do, so that won't be a big deal. Alright, so, cool. I will keep plugging away at the Admiral as quickly as I can. Now I can finally get rid of those pesky old mica caps. All you gotta do is heat up the joints and slide this up. That's all there is to it. You can see the corrosion on the back. And then just tack the new one in. And I'll do the same for these. These are a little bit trickier because they wrap all the way around and there's a wire above them. So for these I'll take my little wire nippers and kind of chip away at the mica until we get it all out of there. The combination between doing that and heating it up a little bit. I'll do these tubes out of the way as well. And then I'll do a similar deal, take the new mica caps and wrap the leads around. And there we go. A little bit tedious, a little bit nerve-wracking, but the new caps are installed and the coils still have continuity. Now, I would like to point out that this is not typical. Video IF coils, I don't think ever have mica caps like this, and it's pretty unusual for the audio. Other than a few Admiral models, I've never encountered this before or heard about anybody else encountering it. So if you think about getting into this hobby, don't expect it to need to be doing anything like this, this kind of surgery. I know it's typical in radios from the 50s, but it is not typical in TVs. Well, I can't avoid it any longer. I have to just dive into the biggest mess in the set. I've been slowly working my way up this terminal strip, and I basically just took it down to bare bones, and I'm rebuilding it. I don't think I've ever seen such sloppy soldering before. See, there's still blobs of it that fell off while someone else was working on it on the insulation. I've been picking that off as I've been coming across it and cleaning up the terminals one by one. There were some that appeared to be shorted together from big solder blobs that I had to clean off. So, yeah, lots of double, triple checking the schematic and the values that are there. And, you know, I can excuse some things. Sure, I mean, a repair shop that's still in business is very unlikely to be familiar with a TV made in the late 40s. I get that. Or with the types of tubes used, old flybacks and all that. And I could even forgive maybe some of the incorrect component values, or certainly using the wrong types of ceramic temperature coefficients and stuff like that. But come on, soldering is soldering. Whether it's modern or old, do a neat job. I've even replaced some of the wirings. The insulation was just too fried on it. Now, there do appear to be some unused lugs. So this lug down here, second from the bottom, appears to have never been used. And there's one up here where they had installed a filter cap. By going off my reference photos, it looks like it was also originally unused, and the wire from this connector did originally go right up to this filter cap, and that was used as a tie point. So I think they cut the wire, wrapped around an unused terminal point next to a ground lug, and installed a cap here, which is not unheard of for me to do as well. So I don't particularly have anything against that. But it doesn't do us any good because we got this mess up here. So since they added a terminal strip up here, I mean, you could just as soon leave that wire continuously unbroken up to this point and have installed a filter cap up here next to where it was originally. So I don't think that really saves us a whole lot, so I'm inclined to put it back the way it originally was and deal with this. And yeah, so still haven't come up with a solution for this. Of course I could restuff the cap. Awkward to do. It's twist lock. There's 4 lugs on this, and I believe all 4 of them have stuff soldered to them. This one in particular has got a big solder joint right to the chassis, and the others actually have component leads going to them. So I would need to remove the leads, untwist and unsolder all 4 of those to get that cap out, such that I could restuff it. And then of course there's the work in restuffing it and then remounting it. And yes, I know that there is a E-cap little circuit board thingy you can mount new caps on and install it on a chassis. However, that is for the type that's an insulating material, phenolic type that attaches to the chassis with screws. This isn't that type. That type does not seem to me to be really suitable for replacing twist locks. I would need to drill holes in the chassis to mount it, and I don't see that saving me a whole lot. So what I'm more inclined to do is to install a terminal strip, a better terminal strip. That's one that's got 1 or 2 more lugs, including grounding lugs that come up, and secure it better than just with one solder connection to the chassis. And totally disconnect this original filter cap here. And now for another head scratcher. Been wondering, what the heck is this 82K resistor doing in the middle of all this horizontal circuitry stuff? It's got an orange wire going all the way over to control in the front. And then on either side of it, 2 red wires are going way up over here. In other words, it has nothing to do with this stuff down here. Well, that orange wire, if we trace it out, goes to the center of this control, which turns out is the contrast control. And if we look carefully on this lug, there is a red wire that's going directly to 6AC7. So 6AC7, pin 6, center tap on the contrast control, exactly as it should be. Supposed to be a 10 microfarad cap in there somewhere, which I may have removed while I've been cleaning things up. Simple enough to install that somewhere. But where is an 82K resistor? And what's it going to? Well, the other side goes to a red wire that goes to pin 6 on the sync separator, which is this guy. And yeah, 82K resistor, and it goes over, and it's supposed to go to this point, not the wiper on the contrast control, but a junction between these 2 resistors going to the brightness control. Which also goes off this way, which is actually the low voltage power supply, I just realized. Confusing where they drew this schematic. So possibly the schematic's wrong. The Wallace Telly aids are generally pretty reliable, but I'll compare it to the Riders, original Admiral service info and so on, and the SAMs just to confirm. But what also is throwing me is this red wire looks new. Newer. So here's like an old red wire. And here's one of these I've been looking at. In general, the original wires are dull and a little dusty. Here's another old red wire. We got this one. And the one going to the 6AC7 looks awfully new and bright. And here's a new wire I just installed. So, was this a modification? That's what I'm getting at. Well, it looks like an old resistor. So, again, gotta do my homework and try to figure out what the heck is going on here. Perhaps it just occurred to me that the wire that I said I routed over here and cut maybe and used this lug, that is what's supposed to be going to this side here. Maybe there had been a wire here, and while cleaning things up I removed it. I'll have to again refer to my original reference photos, but that seems like a really odd, awkward placement for all of this stuff. I mean, geez, if I got some room somewhere else, take this resistor, move it up here, and move all this wiring up here. Why run two wires all the way down here for one stinking resistor, and then have a wire going all the way up here? Move all the stuff up over here. I did a little research, and I'll keep this short and sweet. This was a production run change. It does seem to be wired incorrectly. There were two unused terminals on this terminal strip, and at some point this change was made. Could be factory, could be done by a service tech way back in the day when this set was brought in for servicing. It was a recommended change to make. So basically, instead of having a fixed voltage on pin 6 of the sync separator tube, it's routed through the contrast control. So as you vary the contrast, you vary the operating point of the sync separator tube. That enhances performance. Okay. So in total, originally there were 4 unused terminals on this terminal strip. This one that's still unused down here, these two, and this one up here. I still think that's a lousy place to put it. I get why they did, because there were unused terminals here, but I think it makes a lot more sense to put it over here so we don't have these wires running through an area where we've got the horizontal oscillator and horizontal output tube and a lot of noise going on. So I'll see if I can move that a bit. Speaking of the low B+, let's look at that circuit for a moment. I think I incorrectly identified this as a 5Y3 earlier, but it's actually a 6X5. So, lower voltage secondary winding on the power transformer, rectified, filter cap, filter choke, goes through the connector, goes over to the brightness and contrast. So the contrast control has the low B+ on one side of the wiper. We got the wiper 27K to ground, so it's a voltage divider. So this voltage goes to the video amp, but now that with the change, there's also, it's connected via an 82K resistor to pin 6 on the sync separator. So what else is this lower B+ for? It's for the video IF and AGC. It's for this stuff. So that's this bus right here. So it goes to the cathode, actually, of the AGC tube, and via a 1K resistor to, I believe that's the screen, and a 1K resistor to the screen, and down and around, and 1K resistor to the screen. And you'll see that again and again in a lot of early IF stages where they have a B+ rail and a 1K resistor and a 1K resistor and a 1K resistor and a 1K resistor and a 1K resistor. That's a real common design. I don't know if back in the day they would license designs from each other or steal them or use published, well-known circuits, but you will see certain elements again and again and again, and that is definitely one pattern you'll see repeated over and over. Alright, so I mean, if when you look at the photo in the SAMs, they have a really clear shot of this area. There's only two parts down here. There's a big resistor on this side and a big cap on this and nothing else. And you saw when I started here, there was a whole bunch of junk down here. So I cleared most of that out. Well, I'll just keep working my way up through here and start putting in those new ceramic caps and get rid of this ugliness. Alright, executive decision. That is where the low B plus filter cap is going. I traced out the wiring and it goes more places than I realized. So bear with me for a moment. So right now, it's going off this connector, going over here, blue wire, go up to the new terminal strip, and that's where the filter cap could possibly go. And then it continues on over to this tube, and loops around, goes to this terminal strip, you get a wire over to this point, then up into the IF, and then down here to eventually the controls up front. In other words, this seems like a pretty good distribution hub where it's feeding three other areas. So I propose to take and route the power coming in right from the connector and go to this point, filter it, and then have it go off to the various destinations. Cap is overkill, but that's what came with the set. The original was a 250 volt cap. There's only, I think, less than 200 volts at this point, so you don't need a 450, but you know, that's what we used the cap that came with the set. Ah, that's better. I'm finally digging down into the horizontal oscillator and cleaning out all the ugliness down there. If you're going to invest a lot of time and effort into anything in a TV, I think I've said this before, horizontal oscillator and output, vertical oscillator and output. Save yourself a lot of headaches down the road. So, got all the ceramic caps out, and I gotta admit, I made a mistake earlier because I just couldn't tell what was going on. They did not have three of these caps together. They put 200s in series, I guess, to make a 50. And then near it was, I guess, a 330, a couple 330s. I wouldn't be surprised if the leads were actually brushing up against each other, though, because it was just wired so poorly. So, for the 50, I dug up a 51 picofarad mica cap. It was the closest I could come up with. And for the rest, we've got our C0G ceramic types. So I'll be wiring those in. We won't have to do this kludge because I got a 50 now, and I've got some 330s and 270s, so we'll be putting all the correct values in and trying to do a neater job. And I got one resistor to dig out. Also want to figure out why they put these two plastic film caps in parallel. I'm sure I've got the correct value on hand. And then I still have a little bit of work to do down in this area. You know, given if I had infinite time and patience, it would be interesting to just tear all this down to bare bones, remove all the parts, all the wiring down to the bare terminal strips and tube sockets, and rebuild the whole thing. But unfortunately, I don't have the time to do that. But making pretty steady progress. So I'm gonna blow through and redo this stuff. And then as soon as I can figure out where to tie in the last bit here, I think it's time for a power up.